Okay, welcome everyone. I'm going to go ahead and get the meeting kicked off and started. Got a few things to discuss. Let me share the agenda as soon as I find it again. Here we go. So today we got a couple of higher level topics to talk about. The first one, we'll get into the first one to start with. We want to look at splitting the API repository. Reasoning behind this is right now, every time we make a change to a protobuf or add new protobufs, we have to go through, generate the files, and put that in as part of the check-in. The proposal that's out there that I think we've discussed this before is to split the repository where we'll be checking in, protobuf sources, documentation. We'll keep that in the current repo, but split out a repo for all of the auto-generated files. This will allow that to be done through an automated process, if I understood the objective correctly. And then that way, we also have a place where we can version and start thinking about how we do the releases. So Boris, I think you and I have discussed this and we brought it up in some of the other topics. Is there any other details that you wanted to bring up about the process?
Just wanted to get an idea from the group what people thinking of. If any objections doing that, because technically, obviously, it can be done. And from the protobuf ecosystem that we see in across the industry, there is really split view on this problem. Some prefer to keep in the same repo.
Recording in progress.
Sorry, I had to switch to my computer. So some still keep the protobufs in the same repository sources and generated the PB files, and some prefer to split to a separate repository. I think at this stage, I'm more comfortable of splitting and keeping the current repository just for the sources and creating a new GitHub repository, which will be automatically updated with generated protobuf files. So I just wanted to hear kind of people pros and cons on this, because it's kind of big change, changing repositories, and I prefer to do it early. So right now I want to kind of decide on this and make a split, because if we are promoting APIs to beta, V1, and whatever, keeping them and breaking those repositories is not going to be easy change. So prefer to do it early.
No, thanks, Boris. No, I think it'll make it easier, at least in terms of check-ins for protobuf sources. That way, you don't have to go through the generation process, or when you're in the midst of a check-in, you find out you missed something, and etc. So, because it'll be auto-generated. So, any feedback from the group? Sorry.
Yeah, just to add one more comment. Part of the split, we're also going to transition to use a new buff builder. Buff builder allows us not just to define simple YAML files with all the definitions, instead of keeping make files and command lines with protoc compilations. So we want to move to Buff. Buff also allows us to keep track of breaking changes as we go forward. So part of this splitting on two repositories is going to be also changing the build system to Buff build. Any feedback, positive, negative? Yeah.
Yeah, any feedback from the group?
From my perspective, I mean, I like that having everything in one place, but if you think that the two repos, the two separate repos, will actually help the overall process, then I don't have any objections. I'm in favor of that.
Boris, how are check-ins going to be there? Like, are they going to be coordinated? And if so, is it going to be automated?
Yes, I plan to do automation, absolutely. So every time we make a change in the source repository, automatically we will create a new commit in the auto-generated repository. So the auto-generated repository is absolutely going to be read-only from the user perspective. Nobody will propose any pull request there, and everything will be automatically auto-generated. If source repository is going to update any documentation files or helper files that not affect protobufs, the benefit is the auto-generated proto repository will not be updated unless there is a change in actual proto files. So every time before the commit, obviously we're not going to do empty commits. So every time we commit, if it's an empty commit, that means no protobuf actually changed, we will not commit it to the auto-generated repository.
Okay, I think this proposal makes sense to me. Especially the readers and the writers are different in this case now. People who are using the OPI APIs don't need to bother how this gets generated and what happens, and they don't need to deal with the interfaces of the APIs being proposed. But at the same time, you know,
this will eliminate all the random make file, commit your generated file by yourself. All of this nonsense that we are doing today is going to be kept away. And since we're using buff build, buff also allows us, I posted a link in the chat, buff also allows us to commit the schema into the buff schema registry. So it will also be available from the buff build schema registry, as well from the GitHub repo as well. This is what Google is also doing and many others. So you can also check how this process works. So this is what my aim is, at least in doing.
Makes sense. It's a good step, I think. Yeah.
Any proposal on the naming of the repo? I was thinking keep similar name, remove the OPI prefix, and just have API repo. So OPI project/API, that's it. We can also do schema generation according to language specific things, which is very popular in the industry. So it could be something like -go a suffix or something like that. Also very common. But if you have any proposals or anybody have any proposal on the naming schema of the new auto-generated repo, you're always welcome.
All right, I think we'll take this one forward. We should go ahead and move forward with it, Boris. I know you've been working forward for that. So you've already got a lot of the things, or at least started to map them out to get them in place. That's definitely something we can move forward with. Okay, no objections, no issues.
To make people more comfortable, I also post a nice article from medium.com on how to use buff build to generate gRPC code. So people can read it offline. If they are not familiar with a buff build, this is a nice article to start with.
Great, thanks, Boris.
Thanks.
Okay, the next item that we have on here is transaction support. I know this is something that has been being talked about in the EVPN threads. The basis of this is that as we put a database in for the EVPN example that we're doing out there, the question has come up is, where do we do transactions? Do we do it in the backend database, or do we let it happen as part of the gRPC? So this is kind of an open topic to discuss.
Yeah, this came from the private conversation with Dimitrios as well. So we are in the process of choosing the right abstraction for persistence. So we are introducing, not just for EVPN, we are introducing Go language repository design pattern to abstract the actual data store. And we have chosen one proposal, Go KV repository, which gives a very good abstraction layer, as well as a huge amount of different implementation for the database, including Redis, in-memory database for mocking and debugging, BadgerDB, like a huge amount of changes. I will also post a link to this repository so you can look it offline. So once we're doing this, currently in progress, the concern came about atomicity and transaction support. For example, Dimitrios, you want to give an example when deleting an object?
Yeah.
Mhm.
So on top of the protobuf VRF object, gRPC objects that we have, we will have like an overall object internally that we will hold also on extra fields additional information for fast lookups. And that means that when we, for instance, one example could be that when we delete a logical bridge, then we would like to check first if there's any bridge ports attached on that logical bridge before we delete it, because if it is, then we want to cancel the operation, right? So that means that we need to have like extra fields on the logical bridge object, let's say, which is our internals, and they will hold a list of bridge ports maybe. So we can check fastly if there is any bridge ports attached or not. That means that when we create a bridge port, we need not only to create that bridge port to the database, but also to update the logical bridge object with an extra bridge port on the list that is attached to that logical bridge. That means that in one operation, when we create an item or when we delete an item, we need to touch more than one object in the database. And we do not want to have like for these operations unique sets. We want to have unique transactions, but we want to do that under one transaction for performance reasons mostly. So I think that the implementation should not be abstracted and use Go KV, but we should have our own implementation of Redis and InfraDB in the EVPN Gateway Bridge project.
An opposite view was proposed by Ben from Intel, now NVIDIA. He suggested to implement transactions on the gRPC side, which means going to be a new gRPC call that, start transaction, then you'll do all the transactions that you need, update all the objects, and then you commit the transaction from the gRPC perspective, and not doing the backend transactions like Dimitrios is describing. So we, for example, delete logical bridge, which is a single gRPC call, but on the backend itself, it will generate several transactions to the database, several operations to the database that we want to aggregate into a single transaction for atomicity, for example. So that kind of maybe alternative view. I'm not sure. I don't want to say what I prefer. I want to kind of this open for discussion. And Venkat here is very familiar with how this is implemented in Sonic, because Sonic has exactly the same constructs like Dimitrios is proposing in EVPN Gateway, which has a config database, and all the gRPC operations goes to the config database. And then there is a pub submodel from the config database to the actual implementation to the underlying hardware. And they're also using Redis in the middle. So maybe Venkat, you can also kind of chime in and explain what is the view from the Sonic perspective. Maybe we can learn some good design patterns.
One thing to say, Boris, is like really quick before Venkat takes share his view, is that the reason that we would like to also use Redis is because we are going to use pub/sub mechanism of Redis. Because as you already know, the FRR and the Linux configuration will not be monolithic, but it will be changed and be like more modular in different modules, like FRR module and Linux module. So the plan is to when we touch an object on the InfraDB, then we use the Redis pub/sub mechanism in order to notify those modules and take action.
I understand, but frankly speaking, we can actually divide this into two different things, which doesn't have to be the same implementation, right? Because what you want to do logically is you want to first persistently store your object in the database, right? And then you want to publish the change over some kind of pub/sub mechanism. By chance, you're using also Redis to the pub/sub, but the interface is completely different, and actually it's not using the same database that you're actually storing to do the pub/sub. So potentially, I'm not saying this is the right solution, we can use one implementation for just storing the object and completely another solution, like Kafka, for example, just for the sake of the argument, to publish the changes, announce the changes. I think it's just coincidentally that we can use the same Redis implementation for both operations, but logically speaking, we can treat them separately unless I'm missing something. Because from my perspective, first we have to synchronously store the object. Only after the store is actually completed successfully, only then we are publishing the change of the object into the pub/sub model, which
That's
can
right.
be whatever. So it doesn't have to be Redis as well.
Yeah, I'm just saying that Redis, if we are going to use it, it will be good to use also the pub/sub. It will be easier. But yeah, we can discuss if we want that or something else when it comes to the channel.
But and even if we decide on Redis today, I think that we need to make an abstraction so we can easily replace it with something else in the future as well. So Venkat, if you know how the transaction's done in Sonic, you want to chime in, or other people, what you're thinking. Like the use case is very simple. We want to delete the logical bridge. Logical bridge has references, other objects reference it, ports, for example. So we need to update a lot of objects in the database as well once we do that.
Yeah, so there are different things, Boris. One is basically when you delete a logical bridge or VLAN, we internally clean up all the associations. That's one thing. Here we need to really see how we are doing it. As a single transaction, are we creating a bridge as well as associating the members? If that's the case, maybe deleting the bridge should clean up all the associations internally. But if you are doing it differently here, maybe we may need to add the dependency there, and if there are associations to the bridge, then you prevent the deleting and deletion of the bridge itself. So I will have to take a look and what is being proposed. I'll update you on that, Boris.
Yeah, so what you're saying is if bridge has association with it, like ports associated with the bridge, we just prevent the bridge deletion. So basically, we can just keep a reference, atomic, for example, reference count or something like that, how many object reference a bridge, and if it's 0, we are safely to delete it, so we don't actually need to store any actual references. And if it's not 0, we just prevent the deletion. But then, if you want to do the deletion, then you'll need to delete ports before you can delete the bridge. This is what you're saying, right?
Yeah, so the bridge port is created separately and then being associated with the bridge, right? Logical bridge, right? Or it's different?
Yes, but also logical bridge has references, have a list that actually, which is not like present in the API because we don't care to expose that to the user, but internally it will have a list that will hold also the bridge ports that are attached to it.
Okay.
No, adding more fields, I don't think a problem, Dimitrios, right?
No, it's not a problem with the more fields. The thing is, what I'm proposing is that when we create a bridge port, You do not only need to create the Bridgeport object in the database. In the same transaction, you need to also update the logical bridge object with the association of the new Bridgeport that has been created to add that new Bridgeport to the list of the field of that logical bridge. So you're touching multiple objects really when you create a Bridgeport, for instance. That is just one example. I think something like this happens also with VRFs and the SVI interfaces.
Okay.
And you
So
want to
basically,
do this atomically. This is a problem, right?
yeah.
Say again, sorry.
You want to do it atomically. This is why you want it in a single transaction.
What atomically means? I don't know that term.
If in the same time another gRPC comes, you want to first commit the first transaction and then the other transaction. So you want to create a sequence. So you want to do some kind of locking mechanism and do this atomically, to do in a single transaction all the updates at once before you start a new transaction to update a new objects.
I mean, yes. I mean, if you if a gRPC comes and touches a different key, right? Actually, in Redis, I think from documentation that I have read is that you can have a watch function that watches the keys, and if any other operation touches the same key of the object, let's assume the same logical bridge, right? Then it will wait until the first operation has been completed, or it will just retry until the lock is free, let's say. So if you have like a logical bridge and at the same time you need to touch the same logical bridge for two different Bridgeport objects, like Bridgeport 1 and Bridgeport 2, because both of those are associated with the same logical bridge, and you need to add that to the logical bridge. That means that you need to edit the same logical bridge object in the database. You will have a watch mechanism in Redis, and the watch will actually check for the key, and if it is the key is, let's say, touched by two different operations, if the same key touched by two different operations, then the first one will return an error and maybe retry, and the second one will succeed. And when the second one retries, the key will be free from the first operation, so it will succeed also the second one. Something like this. So in one transaction, I want to create the Bridgeport. I want to get the logical bridge from the database, to add the newly Bridgeport to the list on that field, on the logical bridge, and to set also and to update also the value of that logical bridge in the database. So multiple operations in one transaction. Does it make sense, or?
Yeah.
Yeah. So the in order to create the Bridgeport, logical bridge is a prerequisite. Basically, that should be existing prior to creating the Bridgeport.
Yes.
Correct.
Yes. Yes.
If it's not existing, you are going to throw an error right away.
Yes.
Okay. So basically, the Bridgeport is not a standalone entity. You cannot coexist without a bridge, right?
No, you can create port, right, Dimitrios? You can create an
Bridgeport. We cannot create a Bridgeport without logical. So which means if you could delete the logical bridge, it's naturally deleting the Bridgeport makes sense.
No, it doesn't make sense, because we don't want to have that policy that somebody can actually delete the logical bridge and then deletes all the Bridgeports automatically.
Okay.
We just want to throw an error. We don't want to actually do that. We should not,
to throw an error, you just need a reference count. You don't need actual the list of the, right?
No, you the list you need for fast lookups, because if you, let's assume that you want to delete the logical bridge, okay? Then you need to let me think.
You just need a reference count. So people that delete bridge ports, the reference count will be decreased every time you delete it. When it's 0, you will allow the deletion of the bridge.
No, I think the it is used also not. This is just an example. It is used also internally for other purposes also, to get some information from the bridge ports. It is not only
Okay.
used. This is just an example that I'm referring to.
Okay. I think Demetrius, there are implementations, deleting the VLAN, removing the associations and all those things. It's up to the, use case or whatever. If you are worrying that, deletion of logical bridge, internally removing the associations is a bad design or something, I think we can design accordingly. But I would like to reiterate here that there are implementations, there are CLI commands in the networking world that if you delete the VLAN, all the associations are internally deleted. So even for the VRF case also, that's how things are being done, in other networking, other NAS. So if you think that's a bad idea, maybe, you can have the reference count and, check the number of associations with the logical bridge when you're deleting the logical bridge and see, if you want to throw an error, let the user explicitly remove the bridge port from the logical bridge, and then once the reference count becomes 0, you can, safely delete the logical bridge.
Yeah, okay, so where we end up, where we conclude. I mean, we need that for sure, because this is how we know it's working. So
the same thing you will do for the VRF also, Demetrius. Like when you want to delete the VRF, you want the unbind the L3 interface from the VRF and then delete the VRF, or how do you do it?
Something similar. Something similar.
Yeah, because there the case is different. The L3 interface can be there as a standalone interface without VRF binding. Because when the moment you disassociate that L3 interface from VRF, it goes back to the default VRF by default. So you don't really need you can internally remove that binding. But whereas the bridge port is created for the logical bridge. So if logical bridge port can't be there as a standalone entity. So it has to be either you need to delete the bridge port, or it has to be associated with the logical bridge. So VRF case is slightly different, and we need to handle it differently, or you want to have the consistent behavior for VRF also.
No, I would like to have the consistent behavior. I think this is how we have already implemented, and as I said, there is a reason for that.
Okay, all right.
Yeah, Boris, can you send me please this gRPC, because I didn't get it like fully what you have described. Can you send me more information on that to just read a bit about, if you have something?
On gRPC transactions?
Yes, you said that there is a...
There is no such a built-in mechanism. What Ben proposed is to actually build something like that out of gRPC. So that is in order to be able to, in one transaction, operate on several different objects. For example, let's say you want to delete all the ports and the bridge itself. So you're going to send, for example, 10 gRPCs, right? Delete port, delete port, delete port, then delete bridge. And maybe you want to do it in a single transaction. So maybe, as Ben suggested, we can create a transactional gRPCs. So we'll have another service in the gRPC, which is transaction. In this transaction, you can have several options like start transaction, commit transaction, abort transaction, and add to transaction. So once you start the transaction, during that time, all the gRPCs you send with some kind of transaction ID, that they all belong to the same transaction. And you don't actually perform any of these operations. You just remember them intermediately until the commit or abort or cancel command comes in. When you send the commit command, then all the gRPCs that send the same transaction are actually executed. So only then you store them in the database. And then you can take a global lock, for example, to do so. So it's all atomic. And if you abort, all of that is discarded, and none of this is actually committed to the database. So that's another way to implement transaction, not on the back end, but actually expose the transaction notice to the user. So a user of the APIs can start and end transactions. And all the object manipulation that happens in the meantime will be associated with some kind of transaction. In order to implement that, we'll probably need a new gRPC service, which is just transactional service or something like that, with several operations, as I said. And then we can do something like that, I guess. So it's, again, it's for debate. I think we need to discuss it, whether it's a good idea, bad idea.
I mean, because I really care about speed, like right now. I mean, right now Redis already supports that, and so I cannot understand why to actually spend I mean, not I cannot understand. Maybe it's like a good solution. I don't know, but it will take for sure too much time in order to get implemented. So it's easier to actually just use what Redis has today, and maybe when we evolve the project down the road, then we can change different implementation in the future. But I prefer to have something that is working first, and it is like, so we have something that is working and it is stable, and even if it is simple and exposes some implementation of the database closer to the OPI VPN gateway bridge, than having like a perfect solution that takes like, I don't know, 6 months to get implemented.
I understand that argument. The problem that I have is in OPI, we just don't focus only on AVPN gateway, right? We have the storage bridges as well. We have a lot of different repositories that implementing that. So keeping the same interface in all of them is very important from the maintainability of the entire GitHub organization, right? I cannot really allow to have different solutions, or it's very undesirable to have different solutions in different bridges because they all have the similar needs. Storage is saving subsystem namespaces and controllers in the database exactly like network is or VPN saving VRFs, bridges, ports, and SVIs, right? So it's very, very similar implementation. So I prefer to keep them the same. So whatever we decide, I think we need to decide as an organization and not just focus on a single repository. So that's why I was thinking that we can start with key value store. It's a good abstraction to replace the key map that we have now. Then we add the watch mechanism in order to do the pub sub on all the bridges, not just EVPN, but all the storage bridges, Marvell, Intel, NVIDIA, SPDK, AMD, and others. Once we have that, then we can introduce the transaction. So this is what my progression was, because the adding abstractions right now, as you saw in my pull request on the key value, is a big step forward in order to avoid the Go map dictionary, which is completely volatile. So we can evolve it like this. We can first do an abstraction, then choose the implementation, whether it's, for example, the Redis, which is fine by me. I already submitted the Redis in the Docker Compose files. And then we can start doing the persistence. Then we can add the pub sub mechanism and split this into several modules that save to the database and then publish and then subscribe to the changes and then actually execute the commands themselves. And after we have that, we can add transactions in order to add atomicity. Starting with atomicity and transactions, I think it's just going to introduce a lot of noise versus a lot of progress that we can make so far with just moving forward with persistence, because I think that's a main goal, Dimitrios, is to first have persistence. If a bridge restarts, we want to replay all the commands first. So we can deal with that now, and then we can change, because it's all abstracted, we can actually change into atomicity a little bit later, because that probably is a little bit smaller priority than just to have the persistence on our bridges. Don't you agree?
No, I don't agree. And I mean, it looks logical what you say, but I don't agree because I know that we have faced several problems internally, and we come up with that design. So if we do not follow that design then I think that we will have more problems. We will need to debug more problems and maybe eventually end up somewhere that is not working.
I don't think we don't get where you want to get. I'm having the problem with the way we get in there. I think that we need to start small because, again, we cannot boil the ocean. We cannot implement immediately the persistent, the pub sub, and the transaction in a single pull request. We need to focus on something first. So I
don't care about the pub sub in a single pull request. We can start with the monolithic implementation without pub sub.
Yeah.
And we can have like the first implementation could be the transaction.
Mhm.
I'm not saying that the pub sub can happen after this transaction pull request gets merged.
Mhm.
I'm not saying to also split the modules and also do the persistency, the transactions. Let's do first the transactions persistency, and then we can split the modules.
Yeah, I have a big problem with tying ourselves into specific implementation, for example, Redis, right? Because as you said, we consider Badger, we have to have in memory for mockery and unit testing. So Go map with a read-write lock synchronization is absolutely a must for mockery and unit testing. So we have to have several implementations at least. I'm okay with choosing another library to do in the abstractions. And if you find a better one, I'm okay with that. But implementing everything with Redis client, I think it creates a bad design pattern because there is a well-known design pattern of repository abstraction in the Go language in order to abstract the actual store implementation from the business logic. If we tie ourselves with a notion of, we can implement all of that ourselves, but there is a lot of already existing repositories that do it for us. So I don't know. I'll keep looking for sure, but
maybe we can schedule like an ad hoc meeting to discuss that in a broader audience. So we is that okay?
Yeah, absolutely.
Yeah, we can do that.
But I feel we need a little bit more homework before we do that, right? Because we need to search for a little bit alternatives and maybe to draw a design how to do it better, and then we can have for sure a meeting about this. Absolutely.
And we want to make the solution to be generic across all the different bridges too.
Exactly. This is my concern because once I have this key value interface, because this is what we're basically doing, right? Even Redis is doing key value storing. So if I have this key value abstraction, I want to merge it into all our bridges, not just EVP and Git. And they all have the same needs: the persistent, the pub sub model, the transactional model. That's all absolutely is needed for all of the bridges.
Yeah, and if there's optimizations that you want to make, that should be done for a specific solution, which would be outside of the scope of what we're trying to do here.
I mean, if you want to create an abstraction, I mean, for us, the transaction we need to have for sure. If that's gonna happen through abstraction or not, that we need to discuss. But this transaction mechanism right now is not supported by this GoKV.
Yeah, GoKV is just one library, right? I saw at least 20 different libraries for the that implement the repository design pattern in Go. So we can keep looking for sure.
Okay,
there
so
is one that Philip and Artyom suggested as well on that pull request. I can pull it and see. If it's
so you're just to get it right. So your suggestion is to create that transaction model that I'm proposing, but in an abstracted manner, right? And not exposing the backend DB into
so we can easily switch. Yeah, so we can easily switch between different implementations. This is why this design pattern is important, right? Tomorrow you don't want to use Redis, you want to go back to Badger for some reason. You can do that without changing your business logic. Today, we can do that by implementing ourselves this design pattern. So creating an interface by ourselves, and then implementing an interface for specifically Redis, Badger, and others. But if you look into the existing GoKV, for example, it has, I don't know, like 20 different implementations. I see BadgerDB, Bbolt, Bcache, CockroachDB, Data Store, DynamoDB.
I have seen that. I have seen that. You're right.
So it's very useful, but yeah, I agree with you that if transactions are needed, we need to make sure we understand how to implement that correctly. Maybe the another idea is not to save that list that you have in the same object, but maybe we need to create another table or another store that will keep only associations between the object. I don't know how to better structure it, but it seems to me that what you're proposing is very tightly coupling between the objects, which I think is a concern for several reasons anyways. So this is why we see this problem in implementation, because maybe the tightly coupling of the objects is the wrong way of doing things.
Anyway, this needs to be discussed, but you're proposing to actually have like a similar implementation like GoKV, but which is like an abstraction, right? It's our own implementation, but also supports like more like transactions and other stuff that
exactly.
Yeah, okay.
Because we need to have interface that have the common functions like set, get, delete, and if you need watch and if you need transaction support, for sure. Because and we need to have several implementations. Redis is fine, but if we can add all of them like GoKV, and we can also go to the maintainers and see if they can support it. For example, I already opened on the alternative repository that we found, I already opened the pull request to add the list method, for example, because none of those abstractions don't have a list. So I'm not sure how we implement the list with gRPC call. None of the key value stores support lists. GoFiber, that's another one. Let me share it in the chat.
Put it in the Slack because
it is another good library as well. Yeah, go ahead. Sorry.
Can you put it in the Slack, because when this meeting is ended, then the links will be disappear from the chat. So can you paste them in Slack so we can have them?
Yeah. Absolutely. So GoFiber that I posted in Slack to you and in the chat is another good library, which is even better maintained. Recent commits from last week even. I started an issue with them to add more functionality, so we can always start discussing there about the transactional model. But it seems to me if there is a library that supports, I don't know, 20 different implementations, it will be wrong for us to actually implement the same functionality by ourselves. It's just a lot of code duplication that we're going to create anyways.
I don't think that will be a problem to have an abstraction. But at least we need to support what we need to support without abstraction.
No, I don't disagree. So yeah, we just need to keep getting it, and I'm feeling that we don't have a right forum to actually discuss those issues. So finally today we're having, I think, a really good discussion, and I do want to learn from existing projects. Right, we are not inventing the wheel here. Right, Sonic is doing ConfigDB for many years, and by Microsoft, so I'm pretty sure it's not a bad implementation in Sonic. So we need to make sure that Venkat and others from the Sonic community can actually help us to build something really good here. I know a lot of people here has combined expertise in a lot of those areas, like Vipin. I'm not sure. You probably have some kind of persistence in the Pensando, AMD Pensando implementation with the database and transactions. So maybe you can also help us chime in and explain what is the right design to implement this as well.
No, I think the discussion that you guys are having is relevant, especially from data path point of view. I can say that you need to atomically commit things. You can't have one table updated and second one is dangling and not pointing to the right one and all that. So it's a hard requirement for many of the deployments that I've seen. Now, how do we achieve that? But at the same time, I feel the dependencies and atomicity are somewhat hand in hand. Having said that, it is possible to have dependency sorted out without creating atomicity. For example, if I need to have references to ensure that you can't delete an object if it's referring to something else, that can be done without atomic transactions. So we should decouple the object dependencies from the atomic and atomicity and all transactions.
I really like that idea. So again, how we can we create a design that shows that, and we can, if you feel more comfortable, we can do it on cloud APIs or in EVPN APIs. I don't really mind. EVPN has only 4 objects, so for me it's really easy to operate on the 4 objects only that we have. But any design in this kind is good by me. So can we together create something? Or if you think this is IP by Pensando, you don't want to expose that, that's fine. If there is something that we can do in open source way together, that will be perfectly fine as well by me.
I think it will be better to actually have a discussion first and put all the pros and the cons of the different implementation and take a decision before we start writing code.
I agree. Yeah, I agree completely.
Okay, so let's schedule an ad hoc meeting and.
I'm just asking Vipin if Vipin can also chime in, prepare something from your knowledge for what you did and how to decouple better objects and remove the atomicity and remove the transactions, so we can discuss pros and cons of this approach versus what Demetrius is proposing as well. So we have alternatives.
Sure. Let me come back on that one, Boris. But I understand the intent of the question. Either way, I can provide the input.
Yeah, because I agree with you, Vipin and Demetrius. I understand your direction. This is great and perfectly fine. But I personally feel, I don't have any evidence to support it, but I personally feel there is something wrong with this approach of tightly coupling all these objects. This is why maybe we see all these problems jumping in, how we update. So I think maybe a data model that we are discussing is maybe inaccurate or incorrect. So I prefer to have a really discussion here, how we map the objects and the models. And I agree with you, let's do that before we jump into implementation.
Yeah, I think, so there are 2 things, right, Boris? One is either you enforce the user to configure the, information correctly in an order, or, you let the, make the configuration loosely coupled, meaning you don't need to worry about any prerequisite. You can independently configure bridge ports, logical bridge, and all those things. But whenever you have the complete set of information, that's when you are going to do next set of actions, either programming to the kernel or programming to the hardware and all those things. So it really boils down to what kind of flexibility we are going to give it to the user, whether you are going to allow user to configure independent of whether the prerequisite present or not, or you are going to enforce the user to give the order in which you need in the backend, so that you don't need to, the backend need not worry about finding out the prerequisite and all those things. When user itself, like, taking care of meeting those prerequisites, then backend, just matter of programming the information configured. Otherwise, you need to, now that we have the DB, maybe it's easy with DB, you put whatever the information received by the user, but in order to do the next set of actions, you need to really find out whether all the prerequisites are met, right? So those are the options. Yeah.
I agree, but what Demetrius is saying, that what we expose to user is a very limited set of APIs,
right?
And we don't expose all the fields. So what will happen, for example, like we saw with I don't remember what, MAC generation, right? So we generate a random MAC address to assign it, right? So this is something we don't expose to users. So there are fields that once user programmed only a very limited amount of data that we allowed him to control, what will happen is the backend, once receives that gRPC call, will do a lot of business logic on this, will generate more data, and then this data will need to be stored. And the question is, once data is being stored, do you need to update a lot of tables at once? That is a question. Once those tables are actually updated, then the actual backend that takes information from the table and programs the netlink, the Linux kernel, for example, or the different hardware accelerations, that is, I think, pretty easy to do because that's one-to-one mapping. But this business logic to database, I think this is what we're currently discussing, and I think it has a still, for me at least, it has gaps. So
Yeah.
this is why this atomicity comes.
Yeah. So the other thing is like this is one thing, user configuration on the fly, and all those things. But when you save the configurations and you restore, the backend needs to really worry about whether the prerequisites are all there, and then we populate the database. So that's something we need to worry about as well.
That is another question I want to bring up. It wasn't on the agenda today, but Dmitry, maybe to trigger the quick discussion, we don't have to deep dive on this now, but maybe for the next time or offline, is we need to implement the code that actually what happens on the initial bridge startup. So the database, let's say we have the persistent database, we load the bridge code, right, in the memory. Now there is some code that have to happen that goes and reads all the configuration from the database and programs all the underlying netlink or Linux kernel networking. But it might be a conflict because maybe just the bridge restarted or the database restarted, but Linux did not restart. So you have conflict on the existing objects already. So how we deal with that bridge restart persistency, that's another big topic, and how we implement all of that. No?
I mean, if the you need to be able to identify the. If we have discussed this in the past, I have to check it and come back. But you have to. I mean, let's assume that you have a power cut, and then the server restarts, and some objects are there, and also your database is full because it was a power cut, and you have persistency, right? So when it comes up again, the VPN gateway bridge needs to actually identify which of those objects in the Linux are associated with the objects on the database and not create them again.
Exactly.
Or delete
that
them
is
and
a lot of
recreate
logic.
them.
Yeah, that is a lot of logic, a lot of code to deal with it. Yeah.
Yeah. So you
haven't
need to have those
done
stuff.
any of
Yeah.
this. Yeah.
Yeah, but I have notes about this. I have created notes in the past. I need to read them, but something like this, I remember.
And Venkat, Sonic obviously deals with that today, right?
Yeah, of course, yeah.
I'm just feel that we re-implement Sonic again from scratch. Sometimes.
Yeah.
Cannot we just use Sonic? Can Sonic do a VPN gateway, Venkat?
Yeah, of course. We have a lot of features in the Sonic, yes.
Yeah, I can do that.
So can we just create those gRPC translations into the Sonic, translate them to gRPC of Sonic, and that's it? And we have the Sonic running on the DPUs? Isn't that easier?
Yeah, that's possible.
Then
Today it's all through a management framework, GNMI interface, OpenConfig based models is what we use today to configure all the EVPN stuffs. Yeah, if you want gRPC, something.
Yeah, and it goes to config.db, and config.db is then translated to netlink, right? So it's all the same.
Yeah, I mean config.db. There's a manager, listening for those config.db events, and then programming the kernel, and then FRR is the one that pushes the configuration to the kernel as well as to the various application DB and other DBs, and then it goes to the SAI database, SAI ASIC DB, and then it gets programmed into the hardware. Yeah.
So why are we doing another implementation of Sonic?
We don't. I mean, to have like our own implementation was a prerequisite that we do all this effort, right? If we wanted to use Sonic initially, then we would just use Sonic.
But we implemented the same stuff: the persistence, the database, the PubSub model, the Redis database. We do that.
Yeah, but for a different process, for the VPN gateway bridge, for it's a different thing.
Why? Sonic can do a VPN gateway bridge. All you wanted to do is change the gRPC APIs that Sonic expose. So we can do that. We can add those gRPC APIs as service and use the same manager and everything in Sonic.
Yeah, there's a schema defined for the config.db. You just need to refer what are all the keys, fields and all those things for the table, and then you just need to, configure it from the gRPC handler. Yeah.
No,
And
I
then
think
we can add
we
plugins, right, to the specific hardware via SI interface, for example, right, Venka?
Yeah.
I mean, if you have objections with the current implementation, we can discuss that in a broader audience. But I cannot agree that we.
No,
can
I'm
use
just
Sonic
saying.
storage. Yes.
No, I'm just thinking
yeah.
out loud that we
Okay.
it's like we're
Okay.
implementing the same stuff again and again.
Okay.
But, I'm not against anything. Yeah, I'm
Okay.
just thinking out loud.
For good topic, good discussion. And we circled back to all the way going back to Sonic again. Okay. So we are at time.
This is what happens when you let me talk, Mark.
It's
Next time,
okay.
just mute me. Mute me.
No, it's okay. It was a really good discussion. So we've made some progress, at least in terms of outlining transaction support. And we also identified we need to set up an ad hoc discussion to talk about this and do some more research. But we are at time. So I'll go ahead and close it out. We can pick up again next week, and I'll put on the agenda about the initial operation, how you deal with bridge restart that you brought up as one of the topics that needs to be brought forward.
Thanks.
All right.
Okay,
Everyone,
thank you,
have a
guys.
good day.
Yeah.
Thank you.
Bye bye.